Hey guys, so we're going to go through Unit 7, Lesson 3, the math problems here. And the good news is if you push through Unit 7, Lesson 2, this is going to be a little bit easier because it really is like almost the exact same thing that you're doing here. So there are three main equations that you need for this lesson. So I have them on these two slides right here. The first equation is this, and it should look kind of familiar. That should say just minus. It should just be G products minus G reactants, right? So this looks very similar to what we did before, except it was H products minus H reactants. And so Gibbs free energy is measuring if a reaction will happen or not. And the values for that are also found in table B12, except guess what? It's not found right here. It's found right here. It's found in this last column right here. So all you do is the exact same thing as before where you plug in the values, except now you pull them from this column. Okay, so this is the first equation that you might need to use. If the temperature is not at standard temperature, if the temperature is not at standard temperature, you will be asked to do a little bit more work. You have to use this equation for it. So we will look at this in just a second when we have a problem like that. So you have to find the H of the reaction, which is the H products, like you do the H products minus H reactants like we did before. And then the temperature is given to you. And then for S, we do the same thing, S products minus S reactants, which is this equation right here. And that also can be found right here. So sometimes when the temperature is not standard, we have to look up like this value called S, which is entropy. And so I will do this problem with y'all so that you don't have to stress out about it. And yeah, there really are only two math problems here. And so that's the great news. Let's look at this one first. It says, calculate the delta GR of the following reaction and state whether it is spontaneous at standard temperature or not. So the temperature here is standard. And so we can use the easy equation where it's just the G products, the sum of G products minus the sum of G reactants. Okay, so what are our products here? Okay, we'll see this arrow. Everything to the right of that arrow is a product. And everything to the left of that arrow is a reactant, okay? So what are my products? My products are CaO plus CO2 minus my reactant, which is CaCO3. So I need to go look up the delta G values of those things. It needs to be the delta G values. So first of all, let's find CaO, which is calcium oxide. CaO right here, and remember we need this value, the negative 603.42. So negative 603.42 plus, and then carbon dioxide, which is CO2. So here is CO2 right here, and its value is negative 394.36. Negative 394.36. Remember, that's what this part is right here. And we're going to say minus, and then CaCO3, which is right here. And its delta G value all the way over here is negative 1129.16. I know I'm not saying that correctly, but I just want to remember it easier. Okay, now all we need to do is plug this into our Desmos calculator. Hopefully you're taking it with me. So write this down. Pause the video for a second and write it down, and then we'll put it in the calculator together on the Desmos scientific calculator. You can say plus negative like this. It's kind of weird to write it that way. You can also just say minus, and it's going to be the same answer no matter what, because plus negative is just minus. And make sure you plug in all your negative signs, and I get positive 131.38. And that should be in units of kilojoules, I believe, because when we look at the guide here, these are in units of kilojoules per mole. And so now let's see if that is an option here for this. Let's see. Okay, so now let's see if that is an option here. Give me 1 second. So this is problem number 13. Yes, okay. So our answer is positive 131.38. And now we need to decide if it is spontaneous. If your answer is positive, it is not spontaneous. It does not happen spontaneously. The reaction doesn't happen unless you put in more energy. If your answer is negative, then it is spontaneous. So because our answer is positive, our answer is yes, it is. I'm sorry, it's positive, so it's not spontaneous. So the answer is no, not spontaneous. So that's your answer to problem number 13. Now let's look at problem number 14. Calculate the delta GR of the following reaction if the temperature changed to 1123. Okay, so this is not at standard temperature. So we need to use this equation here, which means that we need to find delta HR and delta S. Remember that you can find delta HR by doing the H products minus H reactants. Okay, so remember our H products, they are CaO plus CO2. Those are our products minus CaCO3. So we got to go in and look up the delta H values for these. Again, we cannot use this equation for it because now we're not at standard temperature. And that means that some little adjustments have to be made and we have to do a little bit more math to do it. So we're going to look up CaO and CO2. I'm going to kind of quickly plug these in. CaO, which value should we use? Well, we're finding the delta H right now, the delta H of formation. So that will be negative 635.0. I'm going to have you try to look these up as well, and then hopefully double check and see that you got the same ones as me. CO2 is negative 393.5 minus, okay, and now CaCO3, which is negative 1207.6. All right. So plugging that in, and I get 179.1 for my delta H. And this is in units of, what are my units here? We got to be careful here. My units for delta H are in kilojoules per mole. Okay, so I need to make sure to write that down. Okay, so now I have my delta H, which is 179.1, right? I also have my T. My T is 1,123. So you see how I need to plug that into this equation? I need to find my delta S now as well, because that's the last thing I need. So remember that delta S is just the S of the products minus S of the reactants, the exact same thing, but from a different column now. And so for our products, it was CaO plus CO2 minus CaCO3. So now we need to go back and look them all up for the S column. So looking here, CaO is right here. It's a solid. The S column is right here. So 38.2. CO2 is right here, 213.74. And CaCO3 is 91.7. And be very careful here. For whatever annoying reason, the S column is in units of joules, not kilojoules. Okay, so it's in units of joules per Kelvin. So I'm going to write that down, that these are the units here. And now I'm going to solve. I'm getting positive 160.24. And these are in units of joules per Kelvin. I want to convert it to kilojoules because my other units are also in units of kilojoules. So I'm going to convert it to kilojoules. So right now we've got joules. I want to get it to kilojoules, and I want joules to cancel out. There are 1,000 joules for every 1 kilojoule because kilo means 1,000. So I want to get it to kilojoules. So we're going to do 160.24 divided by 1,000 to get it to units of kilojoules. So I get this. I'm just dividing it by 1,000, and now my units are kilojoules per Kelvin. So now I'm going to plug that in. So let's plug that in all right here. My delta H is 179.1 kilojoules per mole, minus my T, which is 1123 Kelvin, times my delta S, which is 0.16024 kilojoules per Kelvin. So my Kelvin will cancel out, okay? And that will leave me with, I think this should also be, these should be able to add together. So 179.1 minus 1123 times 0.16024. Okay, so there you have it. I'm going to have you try to plug those in your calculator. Remember, you only need to plug in the numbers. And let me double check that that gets us the right answer. So you can round that off. If you look at the answer options on problem 14, you know, you can round that off. I am getting, whenever I do this, negative 0.84952. Okay, so it's a negative number. And so when it's negative, that means that it will be spontaneous. So yes, it is spontaneous. And I think that that rounds off. So that would round to negative 0.8 for the answer to number 14. So hopefully this helps you a little bit. You know how to do delta G now. On your quiz, your questions will mainly be like this one, where you just look up the delta G. You probably won't have a lot that are this, where you have to go look up the delta H and the delta S and then plug it all in together. Most of them are at standard temperature. And so you only have to do ones like problem 13 for that. If you have any questions, come to my classroom or come see another teacher, whoever your teacher is, and we will help you out.